bond versus a strontium and a phosphate bond, which one would be stronger? Calcium. So as the strontium slowly starts getting into your body and slowly starts absorbing into your bones, what's going to make your bones weaker or stronger? It could make them weaker. All right. So one of the things, especially if you are a female, that's one of the, your occupational physician, they would get you up and they say, okay, we want to keep an eye on your bones over time. Okay. Because see, here's the thing, as a chemist is being very safe these days especially. There's lots of controls and regulations and fume hoods and everything. But if you're working with you're going to get exposed. I don't care what. All right. And the idea is to minimize that exposure and try to do it safely. All right. What's the point of the story? Right underneath each other from a periodic table. Now, what would you think about something bonded to fluorine? Would that be a strong bond or a very weak bond? Strong. Fluorine is extremely strong. So think about it. You got this, you ate a Milky Way candy bar, whatever. You're watching One Tree Hill and you go to bed. So these bacteria are going to start eating away at the teeth enamel. All right, why? Because they're producing acid that eats away at your teeth enamel. But whenever you brush it with a fluoride toothpaste, what are you doing? You are reforming a bond there, right? So actually, the fluoride bond with your teeth is a lot better than what was originally there. Does that make sense? All right. So now guess what? That bond is stronger. So that means your teeth tend to last longer and decay less and all these other various scenarios. And it's all got to do by looking at that periodic table there. All right. Are there any questions? Okay, so what's the first part of your first exam? I'm going to hand you out a single sheet of paper, and there will be no periodic table to be seen. All right? And I will prompt you in two ways. I might put down FE and draw a blank. I might put down AU and draw a blank, and so on and so forth. Okay? Or I might write down sulfur and draw a blank, sodium and draw a blank, so on and so forth. Now people ask me all the time, they get so worried about this, they're like, oh my God, we got to memorize the periodic table. No, okay, that would be stressful. Here's what you got to do. If prompt one way or the other at this level, you need to be able to turn back something. So for an example, what does Fe mean? Iron. What's AU stand for? Gold, right? That's not silver. Ag is silver. Totally different. Sulfur is what? And what's sodium? Na. You would be surprised that the people, probably two of you in this classroom, could put down that sodium is S. That's no good. All right? Sulfur is S. And see, it's those type of things that we want to correct before we get into College 1 chemistry. All right? Not can you draw up 118 elements and by memory know that it's scandium, titanium, vanadium, chromium, manganese, that's just too much. But you certainly need to know that Mn is manganese and Mg is magnesium. Now, is there any questions about that? So then that's going to take you 5 minutes. Who knows how long that's going to take you. And then you're going to turn in the test. And then you're going to pick up the packet. Okay, this is on Thursday. Pick up the packet, and in that packet you're going to have a nice periodic table. You're going to have your conversion factors. You're going to have your scratch paper and all this. Does that make sense to you? Okay, so that's how that's going to work. Any questions? All right, so now let's get into Chapter 3. Okay, so we've got our groups up and down there, and we've got families going across. Now, if you look at lithium, sodium, potassium, rubidium, cesium, and francium, some of my colleagues, whenever they do this chapter, they say, go home and read it. But I can't rationally do that. I mean, I am giving you a lecture on it, okay? These compounds here are called alkali metals. Take note, hydrogen is not one of them, okay? So an alkali metals is everything in this group right here from lithium through francium. Okay. Now, who's heard of an alkaline battery? Or who's heard of something being alkaline? Well, they're talking about generally basic. If you talk about an alkaline situation, it's generally basic, which means pH is greater than 7. And these right here are called the alkaline earth metals. All right, and they consist of beryllium, magnesium, calcium, strontium, barium, and radium. All right. Those are called the alkaline, like an alkaline battery, earth metals. All right, now let's just stop for a minute and go over to the other side of the periodic table. Okay. Now, to my knowledge, the boron group does not have a name. Okay. The carbon group doesn't. Now, the nitrogen group does. It's not in your textbook, but they're called the pnictides. All right, don't need to write that down. And the oxygen groups are called the chalcogens. Again, that's not in your textbook, but those are names. But here's what's kind of important. Fluorine, chlorine, bromine, iodine, and astatine, these are called the halogens. You know, the same thing you're talking about with the halogen lamps. All right. And then helium, neon, argon, krypton, xenon, and radon, these are called the noble gases. Now, the noble gases' claim to fame is that they generally are not reactive. Okay? Helium does not react. Neon does not react, okay, with other things. They're wonderful bath gases. They're great to put in these fluorescent lights up here. When you put a voltage across them, they do these electronic transitions and so forth. Now, I did not say that people have not gotten them to react. All right? XeF2, xenon difluoride, and xenon tetrafluoride are two wonderful examples where xenon does react with something. Okay? But that being said, this type of chemistry right here tends to be very rigorous. All right? And when I say rigorous, I'm talking about stainless steel vacuum lines, extremely cold temperatures, extremely hot temperatures, high voltage. Chemists are missing body parts. No eyes, things like this, all right? But you can use fluorine a lot of times to make things react that typically do not, all right? It's not a peaceful situation, but it can happen, okay? How are we doing so far? Okay, now, in the periodic table, there is a stair-step line, like this right here. Has everybody located that stair-step line? Okay, here's what that signifies. Things on the left of that stair-step line are metals. Okay? Now, what do metals tend to be like? And again, we are generalizing here. Metals, something like silver, something like copper, something like gold, they tend to be lustrous, right? They tend to be pretty. You wear them in your rings and your necklaces and your eyeglasses or whatever. Okay? They tend to be malleable. And what they mean by malleable is you can make them into something and they tend to stay like that. All right, so you make some statue of some guy, right? And then it's just a statue of that guy and it stays like that. You make a ring, it stays like that, whatever. They tend to be lustrous. Have I already said lustrous? Okay, so lustrous, malleable, ductile. And that means has an ability to be drawn into a wire. Whenever your book calls something ductile, you can take it into a wire. Use copper wiring throughout your home, your house, and such. And it also tends to conduct heat and electricity pretty well. Okay? So like gold is a wonderful conductor. It's heavy, it's expensive, but it's a wonderful conductor. All right? Copper is a good conductor, naturally. That's what most of your wires are made out of. All right? That is everything on the left. So if you're going to list a metal, it better be something on the left. So what are most things then? Metals, right? Most of that periodic table is metals. Take a look at this one. Okay, this goes from 56, 57, 72. Wait a minute. Well, where's the 58? There it is. Okay? So really, if you was to look at the periodic table, and you was to take these two rows right here, okay, and put them on a roller. So you could roll them out that way. So now these two rows would be over here somewhere. And then you could take and lift this up. Does that make sense? Okay, so are these things metals or non-metals? They're all metals. Mm-hmm. So most every